so still the series on surds. The last video I introduced what surds are. Surds are actually irrational numbers written in root forms. Right? Irrational numbers that are written in root form. Surds. What I want to carry on is how do we manage or propagate these surds. So we have so many surds, how do we manage them? And that is what I want to discuss. So if I also have, so I'll talk about simplification of surds, talk about simplification of surds, and also talk about how we rationalize them. So the simplification of surds, we simply manage the surds. And the trick to simplification of surds is simply for we to identify perfect squares. Perfect squares. We will have something like 49. You know the square root of 49 is simply going to give us 7. So we look out for things like this. We have something like 81. The square root of that is going to give us 9, and etc. So always look out for perfect squares. We have 25. We have 4. We have 121, 169, and so on and so forth. So, in that, if I have square root of 75, if I have square root of 80, if I have square root of, let me say, 28, I can actually simplify these. These are surds, but I can actually manage them, to give me simpler surds. So we call that simplification of surds. So, in that we need to have this in mind that the square root of AB is the same thing as square root of A times the square root of B. So have that in mind in simplification. So we need to do that. Now I'm going to write that as square root of 25 times 3. So I'm going to write that as square root of 25 times 3. 25 times 3 actually gives us that. I'm not going to write that as 15 times 5 because I'm not going to be able to have like perfect square. So this can be split this to square root of 25 times square root of 3. So using this principle, I can split this for me to have this. And we know very well that this is 5 and this is root 3. So that is basically a way of simplifying that. This can be written as, I can decide to write that as 8 times 10. I can decide to write that as 8 times 10 or simplify this as 16, can also be 16 times 5. That also can be 16 times 5. And this can be split into square root of 16 and square root of 5, and square root of 16 is 4, because it's a perfect square, and I have this at the end of it. So it's a way of simplifying this, making it look simpler. Same thing with this, I can also bring this to give me 4 times 7. So that can be square root of 4 times square root of 7, and that gives me 2 root 7. So this is basically simplification of surds, how to make surds look simpler and presentable. But that's not all about simplification of surds. In simplification of surds, we can also manage expressions that have so many surds. We can manage expressions that have so many surds. But there is a caution. In dealing with surds. There is a caution, and we need to be very careful. The caution, you will be tempted to say root 3 plus root 2 gives you root 5. You will be tempted to do this, but that is wrong. No way. Please don't do that. That is not accepted. You cannot add 2 surds this way or probably subtract them to have this. So this is not allowed. So whenever we are adding surds, you must only add or bring them together when they are like terms. For instance, you can only do that if you have 5 root 2 plus 6 root 3 minus 8 root 2 plus 3 root 3. So when you have something of this nature, you must be careful not to run into that kind of error. All you need to look out for are like terms. So you can see that this and these are like terms. I can bring them together. So I can have this 5 root 2 minus 8 root 2. I can have it to give me 5 minus 8, and that's going to be minus 3 root 2. And for this and these are also like terms. These and these are also like terms. So I can have this with 6 plus 3, that will give me 9 root 3. This how far I can go with this. Can't do this. You are not permitted to add this way. So that's why I left this as a caution. So all you need to do is to actually collect like terms whenever you're dealing with algebra of sorts, specifically addition and subtraction of sorts. You look out for the like terms and you add the like terms. So I round up the video by discussing rationalization. So how do we now rationalize? How do we rationalize denominator? So it is not always okay to have the denominator to be solved. Something like this. So here you can see a fraction and the denominator is actually a surd. So these are not permitted, not really okay. So what we do is to rationalize. To rationalize this is just for you to multiply this same fraction with the denominator as a fraction. So you have the repeated denominator as a fraction, but really this is 1, so we're not really doing anything. And by the first rule, this is A times root B, and that is going to just give us this. And there's another rule I give, root B times root B is going to give us just B. So this is how we rationalize. I have an example. 2 over 3 will simply give us 2 over root 3 times root 3 over root 3, and that will end up giving us 2 root 3 divided by 3, applying this principle. So that's what we call rationalizing the denominator. Rationalizing the denominator. So there are lots of things on sorts. In the next video, I'm going to be solving a lot of problems. It's going to be a problem-solving class, and we're going to solve a lot of problems that have to do with real numbers and sorts. Thank you very much, and bye.